Yeah,
Okay,
we are
so
live. Yes.
good deal. Um, I'm gonna get this going real quick. I'll explain all the connections here in just a second. You gotta get that pumping. And we'll send this one this way. Turn on the juice. All right, so basic information about what we're doing right here is pulse motor circuit. It's very basic. You got your rotor, you got your coil, you got your switch, and you got your power supply.
Okay, I see the switch and power supply. Do you have any questions about them, or is there anything specific you'd like to know?
Nah, I'm good. Thank you. All right, so you can have two coils in the coil as in a trigger switch, trigger coil. You know, there's a couple things you can do to switch your motor. This is a trigger coil. This is a homemade reed switch, and let's put this over here. Try not to spill anything. All right. So this is a trifilar coil. You got an 18 gauge or 1 millimeter strand, just hooked to the transistor right here. The power from the power supply is going into that mechanism. This 32 gauge strand is what's triggering the transistor. So it's what's doing the switching. Now, what's powering this whole thing over here is the third strand, which is a 20 gauge strand, and it is delivering AC electricity to this apparatus, which is then in turn spending DC, every time the switch hits. So if we turn on,
Welcome to the channel, everybody.
hello, see that we're generating 40 DC volts, roughly, and that's with the motor as a load. So with the motor taking, you know, a certain amount of voltage each time the magnet passes, we have an average of 40 volts on top of that.
Thank you for the like. Drop some likes, hit some reactions. Let us know if you got any questions.
All right, cool. So what we're using as a resistor for the homemade version of the pulse motor is this 1500 turn 32 gauge coil. I'd have to imagine that it's around 200 ohms, in between 150 and 200 ohms. You could test it, but I need to take apart some stuff to do that.
Thanks for the likes, everybody.
Thank you, thank you.
Drop some more likes. Let us know if you got any questions.
Mind you, we're only putting in 6.7 volts and about an amp. So about 6.7 watts. And we're getting roughly 50. It's going up, but I think that's because the switch is getting hot. And it's not pulsing every time now.
Sticking.
Yeah. And if it sticks, it'll go up faster on the meter there.
Let's see if we can pump it up to 10 likes, y'all.
All right, so we're going to get an AC reading off of this one. Wow. See, that's not that much. And that's what's coming off of the output of the trifilar strand. Wow. We're getting way more DC than the AC is going in. And I think that's because we got some good amperage coming off of that trifilar strand because it's a transformer. Has a transformer aspect to it since it's in the same coil as the drive coil. All I know is we're getting a tremendous amount of power out of that trifilar strand. This is output that I haven't seen any other way.
We got 2 more likes to get to 10. Thank you everybody for the likes. Drop
Appreciate
a comment
you.
if you got any questions.
Oh, but there, it sticks. It's getting hot.
See if I can get a close up on that arc there.
And that's, you guys, that's only 6.7 volts in. That's amazing. This is secondary power right here that, it's a 12 volt system. So you're not supposed to get maximum voltage out of it until you like put 12 volts in. And I bet that would be true, but we're getting enough voltage to run this thing at this rate at 6, basically.
So can you run through the components real quick and then point out because the battery, is there a battery hooked up here? Oh yeah, right over here.
It's power supply.
Okay, power supply is the battery this round. Welcome to the channel, everybody. Drop a like and subscribe. Let us know if you have any questions.
Now I could hook it up I don't think the battery would go very well right now. I mean, it's running at 6 volts like this. So if I jack it up to 12 right now, I'm probably going to fry my transistor, and I don't want to do that.
Do you have any Bendinis in here?
On that side, I have a Bendini SSG. It's not hooked up right now.
Hello, everybody. We got 1 more like to get to 10. Hit the like button. Let us know if you got it. Yes, we got to 10. Thank you, everybody.
Yeah. All right, sweet. See, look at how bright those lights are, man. We have a tremendous amount of power going through this thing. It's amazing. And I think it is definitely because of the more magnets, but we're going to do an experiment. We're going to take all the values. We're at 6.7 at 900 milliamps. We're going to change the rotors. And we're going to get a look at the difference in the output on this rotor and the generation on both of these meters.
And it went down to 0. Going down.
All right. So it was around 40 volts with the 9 magnet rotor.
Yep.
We'll put the 2 magnet rotor on.
Maglev. I don't know if y'all can see that. Yeah, there we go.
We got a clockwise rotation.
Hey Mohammed, welcome to the channel. We are experimenting with pulse motors, and this is Papa Bale. Thanks for dropping in.
Hey, what's up?
Drop a like and subscribe. Let us know if you guys have any questions. Let's get the likes up to 20. Wow, that is going.
All right, so the same input, we're at 6.7, 500 milliamps. So that's 400 less milliamps on the draw. But you can see this is going way slower. What's the meter say?
Between 15 and 30.
Okay.
And then this one's a little lower, 3.5 and 3.9.
So, I mean, there is 500, basically 400 milliamps less amperage being taken. And that shows in the secondary.
I'm sorry, Lucas, can you translate that to English? Hello, everybody. Welcome to the channel. Thanks for dropping in. This is Papa Bale.
Hey, what's up?
Drop us a like, subscribe. Let us know if you have any questions. Do you have to spin it first always?
No, I don't believe so. Normally I don't spin it. I usually turn it on to make sure that everything's running smoothly before I spin it. So like if we don't get any amp draw, basically, before we, if we do it the other way, it means the transistor's good. But since I hooked up the second motor, that theory is a little different. You gotta spin at least one of them, especially if the switch is stuck in a closed position, because then everything's shorted out. And these two pulse motors are they're hooked together now. They're not separate. So yeah, I like to spin it first now.
Hey everybody, welcome to the channel. Thanks for dropping in. Showing 57 of you guys right now. That's great.
Awesome.
Drop a like, subscribe. Let's get the likes up to 20.
Let's do it. So I like this amp draw a lot better. I like how fast that's going now. We're using this coil as a resistor. That's 1500 turns with 32 gauge. And I don't know if you can tell, but the arc on the switch is a lot less than it would be without that coil. It'd be a lot hotter. So it's working the way it is because this coil is on it. It'd be stuck. It'd be as you might get a chance to see it stick again. When it sticks, everything like shorts out.
Hey, little Desi. In general, we are running pulse motor experiments with electromagnetism and taking down measurements and using our imagination and having a blast.
So let me do in retrospect. This rotor right here, it generates about twice as much energy, but it takes about twice as much milliamps to run. And it's not twice as many magnets. This is a 9 magnet rotor, and that's a 2 magnet rotor. And so I don't know where that math is going, but
So the right stuff commented, if it can output work from a closed system, then you're onto something. Hey everybody, welcome to the channel. Thanks for dropping in. Drop a like and subscribe. I see we got 63 watching right now. That's great. Let us know if you have any questions.
awesome. So that rotor costs a lot more to run, but it does generate more power.
And I think he was commenting on something you said earlier.
Okay.
Yeah, you're good.
About the shorting, maybe.
Yeah. All right, we got to 20 likes. Thank you, everybody. Much
Awesome.
appreciated.
Thank you.
Welcome to Papa Bale's Pulse Motor Hangout.
All right. So I think the trifilar coil is awesome. If you're going to do both outputs, the trifilar and the typical output, I call it the SSG continuance. Basically, you take the power from the power source and you continue it through the transistor. And the transistor or the motor takes whatever it needs to run and the rest of it goes onward. And that's basically what that does. But the trifilar strand is something totally different. But unfortunately, when you run both of them at the same time, it levels out to equal, what it's supposed to in regards to how much output you're getting. So you'll get less from both, is what I'm saying.
Hi, Jerron. Thank you for the like. Welcome to the channel.
And I'm like, the trifilar strand is such an easy way to get, like, quote unquote free energy, but I mean, when you run both of the outputs together, uh, for example, like, see, right now, the trifilar strand is doing 4 volts. Say I did 4 volts through the output, and instead of getting 8 volts through the trifilar and the output, we get 4 volts altogether.
One of these is about that beeping means it'll turn off.
Yeah.
I don't know.
The auto turn off.
But this is definitely like 10 volts less. And this one's DC.
Yeah,
DC reading,
that's AC over there.
AC reading.
Let's look at the. I want to see this.
Oh wow, that looks beautiful.
Yeah.
Hey everybody, welcome to the channel. Drop us a like, subscribe, leave a comment. I'll get to some of these here. They're coming in.
I love how fast that's going with the 2 magnet rotor. I'm impressed.
So the right stuff was mentioning some Nikola Tesla mechanisms about being able to use atmospheric power to start it rather than an input or a stored energy. So that's...
Oh yeah, I need a receiver for that though. Something to receive that energy with. And there's a rotor directly behind my cameraman, which I would really prefer to use that methodology to run, because it actually has to be on the rotor itself, the power supply. And if it could, you know, just take it from the atmosphere, that would be awesome.
All right, we got it up to 22 likes. Let's get it up to 30.
Awesome.
Welcome to the channel, everybody. Thanks for dropping in. And Yanni's, I like how he explains. We're testing and experimenting with back EMF. The switching in dual coils creates spikes of higher voltage. The polarity does change, but the transistor and the diodes direct the energy.
Yes, sir.
Lead acid chemical.
Yeah, and I've got all 3 phases. I've got the cap bank, I've got the lead acid battery, and then I've got the AC manufacturing of the electricity itself to run a loop, basically. You know, like the output charges the cap bank charges the battery runs the motor, and so on and so forth. But what I really want to do is I want to have 2 cap banks, one for each of the coils.
Hey everybody, welcome to the channel. Thanks for dropping in. Let's get it up to 30 likes. I see we got 97 of us watching right now.
Awesome.
Mohammed has a question.
Okay.
I think the gap between the magnet and the coil efficiency is very bad. Am I right or am I wrong?
Are you talking about the air gap here?
I think he might, or maybe between the input and the output. So I'm not exactly sure.
I'd say it's about 3/8 of an inch.
We got up to 30 likes. Thank you, everybody. We appreciate it. You guys rock.
And this one is, I would say tactically spaced, because I gotta force the switch in front of it to get a good position. And that's good. And I mean, it's working so well with it being like an inch and a half away. That's amazing.
Nice.
Maybe 2 inches.
Welcome to the channel, everybody. This is Papa Bale's Pulse Motors Hangout. We are hanging today, working with some experimentation with this setup. Please drop a like and subscribe if you guys appreciate this kind of content, and let us know if you have any questions about what we're doing. Appreciate y'all.
Yeah, absolutely. So, honestly, right now, I could probably make this loop using the trifilar strand to charge the cap bank, that battery over to the small one, use that small battery to run the motor through the cap. So the cap bank, the battery is virtually dead. It doesn't hold a charge. It just works as a conduit. It uses the lead acid to change the chemical compound of the electricity. It's another, and I'm just thinking that using a battery that's fully charged and working isn't going to have the same effect as using the broken one. So what we do is we send the cap bank energy through the broken battery, and so virtually the cap bank is what's running the motor through the battery, and then the trifilar strand is going to charge the cap bank. So virtually you have a self-perpetuating loop, kind of, but I still think we're going to be spending more than we're generating by quite a bit.
Hey everybody, welcome to the channel. We are coming live to you from Detroit, Michigan. And we'd like to say thank you so much for dropping in. Let's try to get it up to 50 likes, and let us know if you have any questions.
I'm so excited, man. I think I want to do that.
What is the voltage of the battery? I think the broken one, or
It's a 12 volt battery, and this is a 16 volt capacitor bank with 500 farad, so 500,000 micro. I think it would work just fine, like as long as I don't have it too much over the battery's capacity, it would work. But all I'm trying to say is that the 12 volts or whatever, however much I decide to do it, if I decide to do it with 6, the 6 volts that's going in, there's only going to be 4 or so coming out.
So no reply. We are having some fun with some pulse motors. We are taking electromagnetic readings and having a blast. Thank you for dropping in.
Heck yeah.
Alex Hunt is there a load on anything other than it charging itself?
It's not charging itself right now. The load
Okay.
is that the actual load is the motor itself over here. And it's a load on the trifilar strand through this capacitor bank. So I would say indirectly there's definitely a load on it. And the way you can tell that this is intricately loaded onto the motor is that when it seizes up, the whole thing shorts out, basically. So,
Hey everybody, welcome to the channel. I see we have 115 watching right now. Let's get the likes up to 50. We appreciate y'all so much for dropping in. Let us know if you have any questions.
that's a great way of looking at it, though. I think it's, should we hook up the other rotor? Or are we good with the 2-magnet rotor?
It sounds smooth.
Yeah, I like it. Okay, so the only thing that's hooked up, so right now, okay, there's no self-charging going on. I could hook up a self-charging device right now with what I have. I think it would be charging a little bit less than it's, running like it's supposed to. But I'm gonna have to break down my meters and get a reading on this cat bank, find out how much is in it. And I think it'll work out just awesomely because I'm using the trifilar strand. I wasn't using that in the previous attempt to run the self-charging system.
Do we know what the torque is?
I do not
Okay.
know what the torque is. I do not really know how to measure torque.
That is a work. We are definitely working in progress on that with
I mean, you can do
researching
math and all that, but that
calculations,
isn't gonna like give you the torque.
because we need the amount of turns in the coils as part of that calculation.
Well, I mean, I do have most of the turns available,
Right.
so you need impedance.
Hmm.
That would be the amount of layers and amount of turns. So I'd say that's about 35, maybe 40, no, 50 layers of 20 gauge.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. I'm his brother Christopher. And drop us a like, subscribe, let us know if you have any questions.
That's amazing. What does the meter say right there now?
29, 30.
That's awesome. That's awesome. That's why this is going so fast. Because, and it's weird. The amount of AC going into the cat bank is, what I'm saying is more basically than what's being spent. So that's why we have what's left over, about 30 volts. But I mean, when you look at what the amount of AC that's actually going in, it's only like 3.5 volts. So I don't understand. I think it's all the spike in the back EMF that's causing all this. This is awesome. Because it's definitely not the AC voltage being generated through magnetic induction or the transformers. If anybody has an idea as to what's going on there, like why we have so much more DC than we have AC going in, I'm all ears.
Hey everybody, welcome to the channel. Thank you so much for the likes. We got 34 likes registering right now. Let's see if we can get it up to 40.
Yeah, heck yeah, let's do it. That's brilliant speed for what's going on here. I mean, it's 6.8 volts in, 0.6 milliamps.
Let me get that on here.
600 milliamps. That's awesome. 500 milliamps. It wants to go down.
Oh, I'm back up again.
Okay. Yeah, it's in between there.
Thank you for the likes, everybody. Let's get it up to 40.
All right, let's do it. Wow, that's getting faster and faster, isn't it?
It is. Germany's in the house.
Germany!
The voltage is right at 29. And it's not touching 30 right now. Where it did. There it went to 31 just there. Okay. And here's the
Is that still on the oscilloscope?
heartbeat right here.
Here, let's
To get measurable data and keep pushing the boundaries of what's known to, generate more output than input. But that's, everybody's working on that, so.
I think with more speed and as John Bedini put it, more speed without a capacitor is virtually increasing the frequency is how you're going to get more than what you put in.
And we got a comment saying maybe the wobble So the wobble might be taken away from some of the efficiency.
Oh, absolutely. I mean, I have a bow. There's a bow in the table that it goes like this.
Oh yeah, let me.
Absolutely. This is imperfect by all means, but still, it gets the point across, I think.
We're definitely bootstrapping it here. Take a look at our memberships. Uh, we love you guys. We can do one-on-ones and collaborate and spread the knowledge.
Yeah, I'm more interested in what you know. So, I'm seriously, I like to pick the brains of people that, see here, it's stuck. People that enjoy doing this stuff and watching this stuff. But I mean, the idea is very much appreciated. But you know, having something to back it up is even more appreciated. So, you know, if you want to talk ideas, we can do that all day. And hopefully maybe we can come up with a practical application or, you know, a method of harnessing the atmospheric energies at the end of the day, and maybe we can come up with something that can be used. I'm really interested in, you know, building things, even though it might not be 100%. What do you call it? This is my style, man. Bootstrap, straight up.
We just hit 40 likes. Thank you, everybody. Much appreciated. Let's keep going. Let's see if we can get it to 50. We love you guys.
So, like, I know there's a bow in this, and I'm planning on redoing the whole thing. Just like maybe putting this one underneath this one so we have two, and there's less of a bow. Or, you know, like putting some wood under there to give it some sturdiness. But I do like the idea of having these holes pre-made and kind of spaced out equally in the pegboard.
Mm-hmm.
So, you know, that's probably going to be something that's going to stay as part of the table, is having the pegboard. That way there's a lot less measuring involved for me, and that's good for me.
All right, so let's go to some of the comments here. From Yanni, I'm just learning there's a lot of energy to be gained, but not like normal output, question mark. We won't see over unity, question mark. But then yes, we do. LOL, the trick is. So I think he's there. I think he's on the same wavelength as most of us.
I wouldn't be able to answer yes or no, but if it's there, it's definitely a possibility that it's there. I'm not saying that it isn't there.
And then no reply says, really, I don't know much about the technical aspects, but I have a crazy imagination.
That's awesome.
And that allows me to visualize and break things down into pieces and rebuild them.
Yeah.
I love that, no reply.
Yeah, that's a great talent, skill. Very useful.
All right, sip of the top. Yanni says, sip of the top, keep it topped up, LOL, and open. Magnetic bearings would be my suggestion for sure from the right stuff. Do we have anything like that?
No, I don't have any magnetic bearings. I just have the magnetic levitation. Still running on regular bearings though. I haven't yet found a magnetic bearing that doesn't require the shaft to be free to spin. All my shafts are sturdy. They're all fixed. I run on bearings alone. And the bearings are attached to the rotor, not to the shaft.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale, and you're hanging out with Papa Bale's pulse motors. Today we're doing an experiment with 2 rotors, and we're taking some readings, and we're having a blast.
Yeah, the homemade switch. I want to grab this rotor real quick, and it's just exemplify.
Drop a like and subscribe. Let us know if you have any questions.
All right, I'm putting a homemade switch on each one of these coils. I think I need to get like a different style because it's just really sturdy. But yeah, man, with 12 volts going through this switch, the only problem is when it's resting right now, it's resting in a closed position. So if I like turned it on right now, it'd be shorted out and it'd be constant on. I gotta fix it. I gotta make it so it's like normally open instead of normally closed.
Is this a teleporting machine? No, it's not a teleporting machine. This is a pulse motor. What if you assisted the rotation of the black part with oscillating magnetic field? Hi Jackson, welcome to the channel. This is not an automatic machine. It does have a power input.
So
That's technically what's happening.
yeah, this I believe because of the way it's set up is an oscillating switch. The energy goes into the coil first, and before it hits the switch, it's got to go through the coils. So AC. And once the AC, and you know what? I made a boast that I could take the cap bank out entirely and just hook it straight up to the coil from the trifilar strand. I don't think I need to prove that point because I'm pretty sure we all know that that'll work.
Hey everybody, welcome to the channel. I show 75 of us watching right now.
Awesome.
And we're up to 44 likes. Thank you so much.
Yeah,
Let's try to get it up to 50 and hit some of those reactions too, if you guys can. Let's spread the word.
yeah, let's do it. So the innovation here really is using coils as resistors. That's one innovation that people don't normally do. And it really cuts down on the heat in the switch over here. It cuts down a lot on like how well it performs. It performs better.
Okay, could you turbocharge it by adding a supplemental magnetic field on top of this setup?
Yes, absolutely. I need a separate power supply, but I could so do that. Like I could use this coil or another coil like it and just hook up a supplemental or a secondary right there and boom. Could even hook it up to this 9-volt battery. And yes, I found a 9-volt battery. But without an alternate power supply, a secondary coil won't do any good. Not really. I mean, you can use the same power supply, but it's going to be drawing, twice as much. So,
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. Drop us a like. Let us know if you have any questions.
Awesome. So, I really think I'm gonna hook up the cat bank and the battery, and see if the coil can't run itself for a little bit.
Thank you for all the likes, everybody. We got up to 46 likes right now. We so appreciate it. Let's see if we can get it up to 50.
Heck yeah, let's do it. So close. All right, I'm gonna grab this battery real quick.
Yep.
I think my daughter should be home in a couple minutes.
Yeah. It's got to be 320. 317. Connected to an exercise bike. Lucas. Let's see what else. Okay. Find a natural source of energy like a stream. Create a penstock to reduce water down to 2 opposing nozzles and blast an impeller connected to an alternator. Right on, Lucas. That is sweet.
Yeah, I'm dying to see that one. Heck yeah, that sounds.
And then connect it to an exercise bike. I love that. Oh man. All right. 50 likes. Thank you, everybody. Rock and roll. You guys are awesome. We appreciate y'all. Let's keep it going. Let's see if we can get it to 60.
All right, we're just checking to see how full this is. See if we need to charge it up any. It's got 10 volts in it. I think we're good.
Have you ever heard of Joseph Newman's Big Eureka?
I've heard of Joseph Newman. Haven't heard of the Big Eureka. Is it his Newman motor just a big one?
Are you using neodymiums?
Yes.
How do you say that?
Neodymium.
Neodymium. He's a sweet dragon shirt, by the way.
Thank you very much. Yeah.
That was from Lucas.
Thanks, Lucas. All right, so we're just going to shift the power from the power supply to the battery here. And then all right, I need to, it's just finding the connections, but I got them. They're all here.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know if you have any questions about this pulse motor setup. You should get a small solar cell, put it near the window, and run a power line.
Power line? Small solar cell?
Yeah, and put it right over here. That would draw.
Yeah, that would be pretty neat.
Because the
And then I could charge batteries that way.
It's
at
all
least.
passive fusion energy from the sun.
Oh man.
The clip struggles.
Well, left-handed clip struggles. All right, there we go. Now we want sometimes I wonder how these wires and clips get so entangled, you know?
Because you're always doing experiments.
That's a good answer.
You're just clipping and unclipping. But it's constant, so keep going. And most of it's recorded on the channel, folks. Take a look. There's more than 1,000 videos of us learning together and him learning on his own.
All right, let's see.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. I'm Chris, the cameraman, and we're working with pulse motors today. Drop a like, subscribe, let us know if you have any questions.
Oh, those aren't hooked up anymore. All right, I think we just need to hook up this one. Moment of truth. Looks like it's gonna let me do it. Maybe. This is gonna be tricky to get that in there. All right, we're all hooked up. Let's see what happens.
Yeah, thermodynamics plays a huge role with all this. The hamster wheel, I hear you. He's saying rodent power could make it happen.
Rodent power. Absolutely. We need to get a reading on this, and there's no more room to hook up a reader to it. Oh, we could use the other one. We could use the probes.
Everybody, welcome in. We got it up to 53 likes. Thank you guys so much. Let's see if we can get it up to 60.
So now I moved the trifilar strand to the cap bank. The cap bank is now feeding the battery, which is dead. It can't hold the charge. It's about 2.5 volts. So the cap bank is going through the battery, and it's also being charged.
That's nothing. And that's going fast.
I would like to see how fast the cap bank is draining, because I am charging it at the same time.
Drop us a like if you like that. So no power input, but stored power loop.
Yeah, I can't do it. I can't shake it too much. It's all the coffee I had this morning.
That's all right. Yeah, don't try. Because I gotta,
But if I had the probes, I could just shove them in the holes.
right, I gotta go for an appointment here in a little while.
Okay. Alright, so I guess I'll leave that run for a little bit.
55 likes. Let's
Hey.
keep it going. Yeah, we love you guys.
Heck yeah, man, this is great. Alright. I'm wondering, so we're getting some definite AC feedback from this coil, the red one. Because that's the only thing that's hooked up to the cap bank right now, and we got lights on.
So that's EMF,
Yeah, that's just
back EMF.
it's just spinning so fast that it's interacting with this coil now.
Got it.
So that's just regular EMF.
All right.
See, now what we could do is, and this is why I brought up having the typical output and the trifilar output combined, is if we did both of them now with this cap bank, if there was enough room to do that, then we'd have pretty much, you know, out what we're putting in, at least really close. But yeah, you can kind of hear it simmering down.
Pakistan is in the house.
What's up?
Welcome to the channel, everybody. Thanks for dropping in. This is Papa Bale, and we are working with pulse motors today, taking some measurements. Drop us a like and subscribe. Let us know if you have any questions. Take a look at our memberships.
Yeah. Don't want to confuse anybody. That's off right now. I've shifted it all to right here, and this is virtually self-charging system that will eventually run out. But with it like this, that battery, it shouldn't even be, it won't run the motor on its own. So
We will check out the Big Eureka. Hey Kelly, welcome to the channel. We are working with pulse motors today. Drop us a like, subscribe, let us know if you have any questions.
So I'm going to try this one more time. It says 5.5. That doesn't seem right. Yeah, maybe 5.5. Was 10. So that's going down pretty fast. But I think the rate that it's going down is slows with the rate that it's moving. It's like the less voltage it has in it, the less fast it disappears. So like if it's going slower, it costs less voltage, basically. Alright, so are we good?
Let's see if we can get it up to 60 likes.
Alright, let's do it.
Thank you guys for all the likes. We're so appreciative. Let us know if you guys have any last questions before we wrap it up. It's been a nice live. Lots of good content. Lots of good comments coming through.
Yeah, really appreciate you guys. So I mean, of all the things that you can hook together without using a diode or anything extra, this is one of the cool things that you can do. There aren't any diodes in this whatsoever, what to speak of. There are no resistors. There's just a cap bank, battery, and connections to the coil. There's a transistor. There's a light for resistance. So I guess there is a resistor.
Hey, Space Frog. He just described a pulse motor setup. We're working with pulse motors today. Thanks for dropping in.
Yeah, so right now, we got a dead battery and a cap bank that's running that battery, and that battery through that cap bank through the battery is running the motor, and then the trifilar strand on the trifilar coil is charging the cap bank. And as you can see, it's not charging the cap bank at the rate that the cap bank is spending.
Okay, but it's still a measurable difference than the power input.
Yeah, oh yeah, it's definitely less.
So we're trying to get it to unity, and then the holy grail is over unity.
Yes, that
Got
is
it.
what most people have a goal of doing, is trying to get more than they, put in. And then we are trying to, what I'm trying to do here is see how long this dead battery will run this motor the way I have it set up.
We got to 60 likes. Thank you so much, everybody. That's so awesome. You guys are great.
Wow.
Keep it coming. Drop the likes. Let us know if you have any questions. Yeah, so we talked about what we wanted to achieve.
Yeah. At least unity is what I'm trying to achieve. At least getting out in some fair form, whatever endless ways we could, harness the energy. At least get out what we're putting in, minus what it costs to run. Because it's going to cost to run something, whatever it is. There's a cost to run it. And yeah, I got the imaginary, like it's floating through space and you flick it and it never stops moving because there's no friction. Okay. Yeah. Wow.
Yeah, it's going.
Yeah, that's going.
I just went.
Yeah, that's going pretty good.
Nice work, no reply. See, when we meet in spaces like this, the convergence of all the energies that we're working with creates like that. So that was an awesome idea, and I hope to see that. So let's talk that up.
Yeah. And honestly, I'm trying to utilize what I have on hand without like either buying new stuff or I can make new stuff with the stuff that I have. Nice. But yeah, we're trying to I don't know, just have fun with it. Not incorporate too much stress in buying stuff, and money's stressful.
Thank you, everybody, for coming to the channel.
Thank you.
Did you want me to just pass you the phone, or did you want to?
No, we can be good. This is good.
Drop some likes. Let's do one last push for the likes as we sign off here. We appreciate you all. We got 60 likes. Thank you so much, and we're looking forward to the next one.
Heck yeah. So thank you very much. I really appreciate you guys. We're gonna close out with the self-charging rundown here, and trifilar coils for the win.
Trifilar coils, y'all.
And we'll check you on the next one. Thank you very much. Bye now.